Festoon system, also known as an open rail sliding contact system, is a viable alternative to so-called and real systems for powering movable hoists, especially in environments like battery charging bays. Festoon systems offer several advantages, including increased reliability due to the elimination of core failures, a continuous power supply irrespective of the hoist movement, enhanced safety by minimizing tripping hazards, and suitability for demanding industrial settings. When considering a Festoon system under the 1999 National Electrical Code, or NEC, several articles become relevant. Firstly, Article 500 deals with hazardous or classified locations. Secondly, Article 670 pertains to industrial machinery. Thirdly, Article 430 covers motors, motor circuits, and controllers. It is essential to ensure the Festoon system is appropriately rated for the voltage and current demands of the hoist. Proper installation and support of the rails are crucial to handle the combined weight of the hoist and its load. The sliding contacts should be designed for uninterrupted contact, preventing arcing or sparking. Overcurrent, short circuits, and ground faults must be protected by the system. Installation recommendations include positioning the rails perpendicular to the hoist travel path. Maintain a minimum clearance of 10 feet between the rails and the floor or work area. Ensure ample clearance between the rails and any obstructions. The system should be installed and maintained by a qualified electrician. Specific considerations must be kept in mind when using Festoon systems. The system must be rated for the hoist voltage and current. Rails must be properly installed to support the hoist weight. Sliding contacts should maintain continuous contact. Overcurrent, short circuit, and ground fault protection are essential. In conclusion, a Festoon system offers an improved alternative to so-called and real setups, enhancing reliability, safety, and code compliance under the 1999 NEC.